Hi guys, this is day 27 of the A2 Economics Revision Challenge, and today we are doing revenue and profits. Our discussion will start with looking at revenues, and when we look at revenues, we're looking at three things. We're looking at total revenue, average revenue, and marginal revenue. Total revenue is the firm's total earnings per period. We say that's total revenue is simply price times quantity. So if you look at a firm's total revenue will be simply, if I draw a demand curve, let's say a demand curve like this, then when we're looking at total revenue, that's basically simply P naught times Q naught. That would be this area under the price and for that quantity Q naught. So total revenue is simply price times quantity, which is the revenue that we get from selling a particular quantity of output. Then comes our average revenue. What is average revenue? Average revenue is simply what we call total revenue divided by quantity. So when we look at average revenue is simply the total amount the firm is earning, which is total revenue divided by the quantity. So it's like revenue per unit. Then comes the third important concept, which is what we call marginal revenue. So what is marginal revenue? Marginal revenue is the what we say extra revenue where we gain from selling one extra unit. In other words, marginal revenue is simply change in TR over change in Q is it's the rate at which, let me write this, it's the rate at which TR is changing as we decide to sell more, and therefore we say MR is simply TR from, let's say, N units minus TR from N minus 1 unit. So for example, TR, if N is like 4, so I'll say that marginal revenue from the fourth unit will be equal to basically total revenue from the fourth unit, for example, minus total revenue from the third unit. So it's the extra revenue that I get from selling one extra unit of the good. So that's what we need to look at. So I'm going to look at two kinds of cases now. I'm going to look at one which is what we call a price taking firm, another one which is what we call a price setting firms, and we will look at how revenue changes for price taking firm versus price setting firm. So before we talk about revenue for these firms, let's talk about what exactly do we mean by price taking firm. So a firm is what we call a price taker if it's too small to be able to influence its own price. It's basically getting the price from the market forces of demand and supply, and it's not setting its own price. And the reason why it's not setting its own price is because it's too small to set its own price. Example could be in a market where there are tons and tons of seller. Let's draw a market like that. Let's say we are looking at a market of vegetable sellers in a mandi or in a market where there are tons and tons of sellers out there. This is like a market where there are too many people that are selling, and if that is the case, then the market looks like this, where demand and supply are basically setting the price. So let's say this is my demand and supply, and let's say the price right now is demand is D naught, supply is S naught, price is P naught. This price will be taken by the firm. So I'm looking at the market. This price will be taken by the firm. So that's my market. And this price will be taken by the firm. Let's call it P naught. And let's say that P naught is like $10. That price is taken by the firm. And that will be what we call the firm's demand curve. So when I make the demand curve, my demand curve will look like a line like this, a horizontal line like this, which is going at the price of $10. Now why is this the demand curve? Well, basically this is called the demand curve because the firm can only sell at this price $10. Can they sell anything above? And the answer is no, because nobody is going to buy from them, because this is a market where there's so many firms, there's so high competition, you can't sell at any price other than $10. Can you sell at a price lower than $10? And the answer is yes, you can, but you won't, because you won't make too much money. So that's basically what the thing is, that a producer can sell at any quantity, be it Q0 or Q1, at the going market price, but will not sell at any price above or below for that reason. Now, when you look at demand curve, we also said our demand curve is our marginal revenue. And remember, marginal revenue is the revenue that you get from selling one extra unit. So let's say if I was selling 10 units, my revenue will be 10 times 10, which is going to be 100. But if I sell 11 units, my revenue will be 11 times 10, so that's 110. So marginal revenue for example, the 11th unit will be total revenue from 11 units minus total revenue from 10 units, which is simply 110 minus 100, which is going to be 10. So demand curve is also our marginal revenue curve, which is an important thing to understand, that when you have a price taking firm, the one that gets the price from the market versus the demand and supply, the extra revenue that they get from selling one extra unit is simply the price of the good. Now, what about average revenue? And the answer is average revenue is also going to be the price in this case, and the reason for this is simply, remember, AR is simply TR over sort of quantities. So TR is, for example, let's say if you want to look at 10 units, TR is P times Q over Q. So I can say this, that I can cancel Q and Q and I'm left with P only, which is simply TR was, if I do mathematically, 100 over, for example, 10, the answer will still be 10, because the Q gets cancelled in the process, and therefore average revenue is also my marginal revenue, which is also my demand, which is my price. So when you are a price taking firm, demand curve is perfectly elastic, and the perfectly elastic means you have tons and tons of substitutes out there, so you can only charge the price which is the market going price, which is $10, and your marginal revenue is also equal to your average revenue, which is also equal to your price, which is equal to your demand curve. So that's something which we need to remember. The last thing that we want to talk about is simply the idea, what about our total revenue? And that's where I'm going to draw this kind of a diagram. For total revenue, we will look at a line that comes from the origin but will be upward sloping. Something like this will happen for my total revenue. Is going to be a graph like this one. Why is that so? Well, look at this, guys. For example, when I sell nothing, my total revenue is 0. When I sell the first unit, if my price is $10, I'm going to make $10. What if my price is, what if I sell 2 units? My price will be $10 times 2, which is going to be, total revenue will be 20, and so on and so forth. So my total revenue looks like this, where it's a straight line coming from the origin, and every time I sell more, I make $10 extra, which would mean if I find the slope of this line, the slope will be change in TR over change in Q, which is simply your marginal revenue. So marginal revenue is the slope of total revenue. So that's what the case for the price taking firm will be, a perfectly horizontal demand curve that comes from the market forces of demand and supply. This brings us to the next sort of case, which is what we call a price setting firm. So for a price setting firm, we say this, that a price setting firm is one that basically has to lower its price in order to sell more. So when you're a price taking firm, you are basically, you have the market power to set your own price, and as a result of this, we say these firms are relatively large and they have some market power, so they have what we call a downward sloping demand curve. So I want to explain the concept that if you're a price setting firm, when you have a downward sloping demand curve, this means that your demand is not perfectly elastic but relatively elastic, which means that you have some kind of a brand loyalty or some kind of a market power, and that makes the demand to be downward sloping. So one such case will be such, like let's say your equation is P equals to, what if I say P equals to 10 minus Q? So let's say come up with the equation of a downward sloping demand curve, which is in fact Q equals to 10 minus P. Let's say this is my equation for demand curve. Why did I choose this equation? Just a random equation, but an easy equation to show our working. So let's draw the diagram for this one. So I'm going to draw a linear downward sloping demand curve for this good. I have a downward sloping demand curve which will look something like this, and the reason why it will look like this is because I'm going to show you this. Let's just simply put a price of 0. When you put a price of 0, Q will become 10. So there is a 10 value here. But when you put a price of 10, 10 minus 10 is 0. So at quantity 0, price is 10. Right? And in the middle, for example, if you put a value of 5, you will realize the price will also be 5. So that's the equation that we have. So if I have quantity here and price here, now I can make a table and show basically how my total revenue behaves. So I'm going to make that table. In fact, I'm going to have Q, P, and then total revenue. Right? So Q would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm increasing my quantity, and I'm going to see, of course, the price will at Q is equal to 0. Price is 10. So price is 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and 0. And then my total revenue is simply Q times P is total revenue, which is going to be 10, 9, 16, 24. I'm sorry, it's not 10, it's 0. That's what I got it wrong. It's 0 because 10 times 0 is 0. 0, 9, 16, 21. Sorry for that again. 21, 21, 24, 25, 5 times 5, 25, 24, 21, 16, 9, and 0. Right, so that's my total revenue. What about my marginal revenue? My marginal revenue simply change in TR as I sell one more unit. So it's going to be like 9 minus 0 is 9. So let's use another color, and I'm going to write it here. 9 versus 16 minus 9 is 7 versus 21 minus 16 is 5, and then 3, and then 1, and then minus 1. So let's use another color for this one. Minus 1, and then minus 3, minus 5, minus 7, and minus 9. So you can see my total revenue is going up first of all till like 5, and then going down. So my total revenue looks like this. So the purpose of this table is just to sort of depict how our total revenue and total cost is behaving. So when we draw a total revenue curve, our total revenue curve will look like this. And we'll talk about this in 1 minute. Y is going to look like this. So this is quantity and total revenue. This is 5. Total revenue rises, and then total revenue falls. Okay, so this is how my total revenue rises and then total revenue falls. So for the first 5 units, total revenue is going up. For the next 5 units, total revenue is going down. So TR is sort of rising versus TR is falling. What about marginal revenue? My marginal revenue, on the other hand, is basically going to look like this. Initially, well, it's a linear line for sure. Initially, it's going to be positive till 5, and then after 5 it becomes negative. So my marginal revenue is going to be like this. Now let's explain why the graph is like this. So remember this from our AS discussion, that in the first, if it's a linear downward sloping demand curve, the demand is elastic initially. Then in the middle, at quantity of 5, elasticity is equal to 1, and then it becomes inelastic demand curve. And I'm going to lower my price. As I lower my price, and a good is elastic. When I lower my price, the good is elastic, right? What will happen to total revenue? Well, if the good is elastic, if you lower your price, total revenue will go up. When the good is inelastic and I'm lowering my price, good is inelastic, which is basically beyond 5, my total revenue is going down. Why? Because I'm lowering my price for the good which is inelastic, so total revenue go down. And that's exactly why when the price is right in the middle, when your MR is total revenue is maximum, so at the point where elasticity is equal to 1, we're saying that your total revenue is maximum, because prior to that total revenue was going up, after that total revenue is going down. Therefore at elasticity is equal to 1, total revenue is equal to 1. Now one more thing which I want to talk about is what about marginal revenue. Look at this, guys. When your total revenue is going up, when you're selling more, that's basically why, because your MR is positive. Each time you sell an extra unit, your MR is also going down but still positive, and because it's positive, it's making the total revenue go up. After that, when MR is cross the zero line, then as you sell more, your MR is negative or less than 0, and that's basically why when you're selling more, your total revenue is going down. But when TR is maximum, MR is 0. So if a firm wants to maximize revenue, we say this: produce at a point where MR is 0, because when MR is 0, total revenue must be maximum. So that's the understanding we need to have. So for a downward sloping demand curve, remember this, that MR is always below the total revenue, and the reason is simple, because in order to sell an extra unit, let me write this: in order to sell an extra unit, the firm has to lower its price, and because the firm has to lower its price, MR is always lower than the price which is coming from this demand curve. This demand curve is also my AR or my price. So that's another thing to remember. Like in exams, they never say that this will be a demand curve. They will call it an AR curve. And the reason why we call it an AR curve is because AR is always equal to price. Remember why? Because AR is equal to TR over Q, which is P times Q over Q, which is equal to price. Okay, so that's the discussion for our price setting firm. And now we're going to move on to talk about profits in this video. When we look at profit maximization, we're looking at first the short run. In the short run, basically we notice that total revenue minus total cost is equal to profit. So we could make three kinds of profits. Where the symbol for profit is pi. We can make basically three kinds of profits. One is what we call profit in the short run, can be what we call abnormal profit. The other one will be what we call normal profit, and the last one is what we call economic loss. Abnormal profit is basically simply total revenue being greater than total cost. This is what we also called sometimes supernormal profit in economics, simply where we say this, that total revenue is greater than total cost, while normal profit is where total revenue is equal to total cost. Remember, this total cost means both implicit and explicit cost. So even your opportunity cost is covered, while economic loss is a situation where total revenue is less than total cost. Now, if I divide both sides by quantity, for example, I say TR over Q, and then is greater than TC over Q, then I can basically also say this, that TR is simply P times Q over Q, and that will be greater than average total cost, which is TC over Q. In other words, price greater than ATC is when you make a supernormal profit. Price equal to ATC, price is equal to ATC is when we make a normal profit, and price is less than ATC is what we say is going to be what we call an economic loss. So we'll see how all the three profits can be sort of three situations of profit can arise, both in the case of price taking firms and price setting firms in our example. So let's now talk about the principle of profit maximization. But before we do so, let's look at profits for a price taking firm. So we said in our earlier video that a price taking firm is the one that gets the price from the market forces of demand supply, but when that price comes, the demand curve is perfectly elastic. So let's make a perfectly elastic demand curve, which is also my average revenue, which is also my marginal revenue, and we know is also our price. So demand curve is like this, a perfectly elastic demand curve for a firm where demand is equal to MR, which is equal to AR, which is also equal to price. Now, we have done in our older discussion of cost, our first thing we remember is that the marginal cost curve looks like this. Our marginal cost curve is a U-shaped curve, which is basically like this because of the law of diminishing return. Because when your MC is going down, your MP is rising, but when your MC starts to rise, that's because of the law of diminishing return setting in. Now, what point should the firm produce? And we say the firm should produce always at the point where MC equals MR. This point A is where MC equals MR, and we say this is the point of profit maximization. So I want to explain this concept of profit maximization, because irrespective of whether you want to make supernormal profit or not, first thing first is that you have to maximize your profit. So why is MC equals to MR a profit maximization point? Well, look at what is happening before Q star. Before Q star, your MR, which is your extra revenue, is greater than your MC, which is your extra cost. So when MR is greater than your MC, MR is greater than MC, then what we say is this, that the profit that a firm makes must be positive. Why? Because extra revenue is greater than extra cost, then extra profit, the marginal profit, as we call it, the marginal profit or extra profit must be positive. And if marginal profit is positive, this would mean total profit must be going up. Why? Because each incremental unit is getting me more and more of profit, so therefore marginal profit is positive or total profit is going up. But what happens beyond Q star? Beyond Q star, what we say is that the marginal cost now is more than marginal revenue. In other words, marginal revenue is less than marginal cost, and this is where what we say is this, the marginal profit is negative. And if marginal profit is negative and I keep on producing more, then the total profit will be falling. So before Q star, total profit is rising. After Q star, total profit is falling, which would mean at Q star, where MC equals to MR, total profit is maximum. So first thing first is this, that the condition necessary for profit maximization is MC equals MR. Now, knowing this knowledge, I can now make the scenario for 3 cases. So for profit maximization, let me write this, profit maximization, which is basically MC equals MR. We're looking at supernormal profit, we're looking at normal profit, and we are looking at economic loss, right? Now, in supernormal profit, my diagram will look like this. I am going to first of all make my demand curve. Step number 1 is to make a demand curve. So let's do that. Demand curve. Let's make a demand curve like this, right? And also let's draw our marginal cost curve. Okay, marginal cost, because this is demand, which is equal to MR. This is marginal cost, and let's do one more thing, which is to draw the diagram again for normal profit, so that we don't need to do it again, and also one more for economic loss. So I may just made 3 more diagrams or 2 more diagrams. So let's focus on supernormal profits now. Now supernormal profits, where I said this, that price must be greater than ATC, because total revenue is more than total cost. So I'm going to make my average total cost in a manner that, 1, it should meet marginal cost at its lowest point, ATC's lowest point, and that my price, which is this one, which is also my demand, let's say price is $10, which is also my demand or MR, should be above my ATC at that quantity where I'm maximizing profits. So my quantity where I'm maximizing profits is Q star. Why? Because we just discussed this, that's where MC equals MR. Now, when I draw my ATC, the way I'm going to draw my ATC is that it's going to be falling first and then rising as soon as it meets the ATC. But at Q star, you can see this, that my price is at point sort of A, my ATC is at point B, which would mean I am making, let's say ATC is like $8, I'm making a profit of $2, which is equal to this region here. $2 per unit, which means let's say if the quantity is like 100, then this P minus ATC will be my profit per unit times Q star. So my supernormal profit will be this region here where price is greater than ATC. Now, similarly, if I want to make normal profit, I'm going to do the same exercise. First, find out my MC equals MR. So my MC equals MR means I'm making Q star, right? But my price has to be equal to ATC for normal profit, which would mean I will have my ATC like this. ATC will be tangent to the demand curve for me to make normal profit. So it's where you place your ATC matters. So once you find your Q star, price is greater than ATC, you're making super normal profit. Price is equal to ATC, you make normal profit. And then when you're making super economic loss, you're going to make a situation like this where price is basically less than ATC. So I'm looking at this kind of a quantity Q star, and my loss is equal to this much because my price is at $10. Let's say ATC is, let's say, at $13. Let me just write ATC is equal to $13, and we're looking at a loss of this much. So I'm looking at Q star to be, let's say, 100. So we're looking at a loss of 300. So price is less than ATC in this case. So again, MC is equal to MR in all the cases, but in all the cases where my ATC is will determine whether I'm making supernormal profit, normal profit, or economic loss. So this is basically the case for a price taking firm. For a price setting firm, however, the only difference that will happen will be what we call the demand curve would be done differently. But before I talk about what happens in a loss, let me just quickly get the price setting firm's diagram sorted, and then we can talk about what should the firm do when they're making a loss. Should they shut down or should they continue to produce, which is a discussion that we want to have next. So for a price setting firm, the diagram will look like this. I will want to make only the first case, which is of supernormal profit, but the rest of the diagram will be fairly straightforward once we get to understand how we draw this diagram. So I'm going to make a demand curve that is downward sloping. The step number one will be downward sloping demand curve. So remember, we'll do monopoly later. So that will be a diagram for monopoly as well, which is the price setting firm. So this is my demand curve. This is my MR. MR is always below the demand curve, as we discussed earlier, because a firm has a downward sloping demand curve, and in order to sell more, it has to lower its price. The average total cost will be, the marginal cost will be like this. So the next step would be to draw marginal cost. Remember, demand is my AR, which is also equal to price, and my marginal revenue is like this. Now, a profit maximizer will produce where MC equals MR. So this is the quantity they will make, and the price that they will charge will come from the demand curve. So that's one thing that we need to remember, that profit maximization happens where MC equals MR. So that's where this point MC equals MR happens, but you don't charge the price on my MR. The price always comes from demand curve, because demand curve is equal to AR, which is equal to price. So that's my price. This is my quantity that I'm charging. Now, in order to make supernormal profit, remember, price has to be greater than ATC. So my ATC will be such that I should be having a ATC here. Here my ATC is basically such that I am making sure that my ATC is below my demand curve, and is below my price at Q star. Why? Because I'm trying to show supernormal profit. So here my ATC will be basically at this point. Let's say if my price is $10, my ATC is like $7, and I'm making a per unit profit of $3, and that's how we show supernormal profit in a price setting situation where MC equals MR, price is greater than ATC, and we're making a supernormal profit. Now, if this was a normal profit case, then we would have a situation like this. In a normal profit, price is equal to ATC. So we will have a situation where price is equal to ATC. The way I'm going to draw that would be where we will look at, just 1 minute, we will look at our curve to be like this, where price is equal to ATC. When MC equals to MR, I'm making what we call a normal profit. And prior to that, I was making what we call a supernormal profit. So supernormal profit for this case. Supernormal profit, price is greater than ATC. When I'm making my MC equals to MR, I'm making sure that price is greater than ATC. For normal profit, I'm going to do something like this, where price is equal to ATC. And for economic loss, what I'm going to do is something like this, that I'm going to basically make the same diagram, but we will show economic loss by doing this. This is my demand curve, this is my MR curve. So demand, MR, MC equals to MR is Q star and P star, and our ATC will be above the total cost curve. So ATC will be here, and the firm will be making an economic loss like this. So 3 scenarios that can happen for price setting as well. One is normal profit, one is economic loss. Remember, all 3 cases MC is equal to MR, so MC is equal to MR, but in this case price is less than ATC. Price is less than ATC. Here we have price equal to ATC. So price is equal to ATC, and in the diagram above we had a supernormal profit where price was greater than ATC. So 3 scenarios that can happen in a price setting firm scenario, for a price setting firm as well. Now, last discussion I want to do is basically what happens when a firm is making an economic loss. So in an economic loss, in the short run, let me write economic loss in the short run, the firm has 2 options, either to continue to produce, or to shut down. Okay, these are the 2 options for the firm. Now, what we say is just that when you are making economic loss in the short run, price is basically price is less than ATC. So your price is such that it's lower than ATC. But in the short run, basically, an important thing that we need to understand is that in the short run, there are some costs that you have to pay irrespective of you produce anything or not, and that is what we call our fixed cost. Fixed cost is what we call a cost that you have to pay irrespective of whatever your production is. Even if you produce 0, you will still have to pay a fixed cost. So let's say that price is basically such that price is less than ATC, but what if I tell you the price is still greater than AVC? Let's say my AVC is $4, or rather AVC is like $8. My price is, let's say, $10. Okay, and what if I tell you my ATC is, for example, in this case, so price is $10 and ATC is, for example, $12. In this case, you can say this, the firm is making a $2 loss, right? Why? Because price is less than ATC, P minus ATC, it's $12. But should you shut down or not? Well, if you shut down P minus ATC, you make a loss of basically $2, right? But what if you continue to produce in this case? If you continue to produce in this case, what you need to understand is this, that if you shut down, whenever we shut down, we have to pay our fixed cost. And in this case, when you look at fixed cost, my fixed cost is ATC minus AVC, which is going to be $4. Why? Because ATC is $12, ABC is $8. So I'm making a loss of $4 if I shut down because I still have to pay my fixed cost. But if I continue to produce, I make a loss of $2, which means that in this case, firm, whenever price is greater than ABC, they should continue to produce, because if they shut down, they will pay a bigger cost, which is the fixed cost. But if the price is less than ABC, this is where you minimize your losses and you say it's better to continue to shut down. Let's say see a scenario. What if our ATC was like $14, ABC was like, for example, or in fact, let's say it was $16. What if ATC was $16, ABC was like $12, and prices, for example, $10. In this case, P minus ATC, my loss is going to be 10 minus 16, or $6 per unit. So I'm making a loss of $6. But what if I shut down now? What if I shut down? Then I still pay a fixed cost of ATC minus ABC of $4. So you can see this, that when the firm is making a loss in the short run, what they need to ask is basically, is your price greater than ABC or not? If it is, then you still continue to produce because you are minimizing your losses by not only covering all your variable costs but some part of your fixed cost. But in this case, when the price is less than ABC, it's better for us to shut down. Why? Because if we shut down, we only pay our fixed cost and do not pay some part of the variable cost that's not covered. So the idea goes this, that firms can in fact, despite making losses in the short run, continue to produce only because in the short run there could be a possibility that they can cover some part of their fixed cost, which is the cost they have to pay irrespective of whatever output level they produce.